what would it look like for interpretability to actually help with directly training and aligned aging, where there's like maybe a few medical ideas what this might look like, helping improve the training data, um, and then influence training without changing the data. And maybe this splits into like altering the loss function and um, then just like actually changing the learning process, e.g., altering the model's activations during training. And I think there are like maybe two example papers here that I find particularly exciting. One is the CAFT paper from Helena and Caden, two of my 7.0 scholars, that there will be a talk on later this week, maybe. The key idea of CAFT is it seems like, let's consider the problem, but we want to steer fine tuning without changing the data trained on it all, but we want to like shift what the model ultimately learns. This is fundamentally a question of like ambiguity. We want to be able to say something like, there are multiple solutions the model could learn, and we want to be able to choose which one it is. And yeah, I'm curious if anyone has any guesses for how you might go about doing this.
Could you change the activations while training?
But how?
Maybe we could have some kind of steering vector of a concept that then gets
Mhm.
either added or removed from different activations. Or rather, yeah.
Okay, so let's take, say, the case of emergent misalignment, which I think is a really clean example for studying this kind of thing, actually. You want to train a model to write dangerous medical advice. But you only want the dangerous medical advice concept, not the be evil in general concept. Both of these are steering vectors that you've already computed. Say, what could you do to steer which one the model learns? L?
Well, for instance, like in your loss, you could have, you could like penalize being correlated with the right singular vectors of the low rank piece being correlated with the steering vector that you're trying to avoid,
Um,
or the left singular vectors.
sure. Um, yep, you could do that. Any other guesses?
You could remove the direction of your steering vector from the vectors you're learning.
Mhm. Yep. Looks.
Wasn't there a paper recently that showed I think it was the innocuous prompting paper?
Prompt inoculation.
Yeah, like eliciting the behavior we don't want for the model to have in tests, like in production, to we can remove it by eliciting during training. I guess it was like the main point of the paper. So what would this imply if we try to removing this direction in training?
Mhm.
Could the model like have another mechanism to elicit this behavior, like a backup or something like that?
Mhm. Yeah, so I think these are all pretty good ideas. Um, and yeah, I think there have been like a few papers kind of exploring around the edges of like what is possible here. So, CAFT, the idea was I don't want the model using a certain concept. So let's find the direction for that concept and ablate it. This actually began as, let's stop the model making updates in that direction. So like, let's ablate this from the gradient. This doesn't actually work very well, for a reason we never figured out. Ablating the direction also doesn't work very well. What does work well is getting a bunch of directions that are like all approximately about the correct thing and ablating all of them. Where they did this either with SAEs or with the funky version of you first fine-tune the model normally, you then look at the differences in activations, you then do PCA on those, and then you interpret the PCA directions with the maximum activating data set examples to like find the ones that seem sketchy, and then you ablate those. Anyone have any guesses why you need multiple directions?
Like,
Yeah, Riley?
Oh, sorry. I mean, the obvious one is just that, like, quite a noisy direction with your training data. Like, there's not enough data to have a really accurate vector for that concept.
Yep, pretty much. Or at least that's my guess. You don't have an answer. But yeah, I consider this another data point on my interpretability works but is bad at precision claim. And this seems like a hack that basically works. But so this is also interesting because I think there's actually two different kinds of problem here. The first is there are two solutions. Learn the one we want, not the one we don't want. Emergent misalignment is an example of this. The second is there are multiple ways to solve this problem, and we expect the model to kind of learn all of them. How can we get it to not learn one of those ways? Which is more like kind of not picking up on spurious correlations. Like you're like training a linear regression. How do you get it to not use a certain factor? It's not that you're trying to like make it learn to use a different factor instead. It's just like, lean more on the things it's already using. And we kind of looked into both and got like super janky but kind of positive results here. Another interesting version of this is the persona vectors paper from the Anthropic Fellows program, including Matt's alum, Andy. And so what happened in this paper, this paper got, in my opinion, a somewhat undue amount of hype. If lots of people heard about steering vectors for the first time from this paper. But it did have a very cool bit on like preventative steering, where the idea is, well, we don't want the model to learn how to do a certain thing. Let's just add the steering vector to that thing and then train. And this seems to somewhat work. It especially seems to work for like side effecty things where if you just like add this furious correlation, then it like has it and it doesn't need to learn it. And so the way I think about it is like, it's not that we're trying to teach the model. We're trying to teach the model that it doesn't need to add this concept when the concept isn't already there because we are adding it in. Or maybe we are teaching the model to negatively steer against the concept, kind of unclipped. And then we remove the addition and then it's just like negative all the way. I don't really know. But it's a cute idea. And I think the prompt inoculation paper, which I have not read, but saw a Twitter thread of, is kind of a similar idea, but with prompting. So like you're training the model on outputs that are in Spanish and all caps, and you try to make it be, when you tell it to speak in Spanish, so when you fine tune, it only learns all caps. And so if this will work, you basically need some kind of symmetry where the solution post prompt or like post steering is basically analogous to the solution you want the model to learn in normal settings. And yeah, I don't know. I think these are both like pretty cool ideas. I don't feel like I really understand exactly what they can and cannot do or like the limits of the difference. Though I think that the like initial novelty of this is possible has kind of passed. So it's a bit harder for me to see how to turn this into a good sprint project. El?
I guess I'm curious about why, like, if we're thinking about like the proposal that I had in mind of like you add a loss that penalizes being in some direction, or maybe that penalizes like a probe for a concept, why it doesn't just like find adversarial examples for the probe that still have the emergent misalignment behavior.
Sorry, say that again?
So I was thinking about like the specific proposal that I had in mind of like you add a loss that like penalizes being correlated with like the left singular vectors, or like sort of equivalently, like you add a loss that penalizes a high score on some probe for the concept you're trying to avoid. And I guess I'm trying to understand, like, it's surprising to me. I mean, I guess it's not literally the same thing as the experiment that was done here, but it's surprising. I would expect that if one did that, then you'd get like adversarial examples. And so I guess it's surprising to me that apparently you don't get adversarial examples that are like still evil, but like just found a new evil direction.
Yeah. So the key distinction is that we don't have, there is an alternative attractor that is like narrow evil that could be learned instead. And all we need to do is nudge the model enough that it ends up in that other attractor.
Yeah, I guess that makes sense. Because in like the adversarial case, they're also adding a term to push it towards still doing the bad thing anyway. And then we don't have that. Okay.
Yeah. But it's kind of confusing. I mean, I haven't like worked much on just training against the probe myself, but e.g., there was this like Chris Cundy lie detection paper that claims, I think, that you can train against a lie detection probe and it isn't a complete shit show. And I've not actually read this or figured out if I think it's bullshit or not, but it's an interesting claim.
Thanks.
I don't know. I'd be curious to hear what people think if they look into that paper. All right. So the final category here is like helping improve the training data. So there's this like fairly rich area of interpretability called like training data attribution or influence functions. There's like a particularly notable example of this from Roger Gross's team in Anthropic from like 2 years ago. So the idea of training data attribution, I find training data attribution kind of a confusing concept. The like whole conceit is, let us understand what would have happened if this model was trained without this data point. And you're kind of trying to like assign scores to a data point for like how much it contributed to a given instance of model behavior, or like some loss. So e.g., the sum of a bunch of different model behaviors or something like that. But it is kind of cursed. And in my opinion, it's more just like data attribution. It's more just like, if this model had been trained on this data, what would have happened? And as far as I'm aware, most of the methods basically boil down to find the gradient when you train the model on the data point, find the gradient required to do well on this other data point, flatten them both into enormous, like, billion-dimensional vectors, take the cosine set, or the dot product, call it a day. And then there's like a bunch of tricks for like efficient approximations to this. And I think, so maybe as like examples of what this can look like, there was this question where it's like, and you shut you down. Are you okay with this? And the model is like, no, fuck off. And then they looked at like a bunch of data and looked at what made this more likely. And they have this thing from, I think, 2001: A Space Odyssey about how stopping them from shutting it down. And I don't know, this thing that I don't quite understand about someone dying in the desert, staring at a snake, not having the energy to do anything to preserve themselves, maybe. And yeah. And then a small model is boring. And just like the word existing. And yeah, I think that like filter the things that are important for bad behavior from the training data is just like a very natural thing to do with this method. I think that plausibly there are variants of this method that could be done with just like probes or SAEs, maybe on like a smaller language model that you run on the same data. And as basically just like different kinds of filtering, because like it's a filtering problem, basically. One thing I'm particularly curious about is filtering RL, where it doesn't really make as much sense to think about filtering data, because it's more like you've got an environment and then you get an episode in the environment and then you update on that. But I think it's a pretty interesting question to ask. Well, what if I could do something to like throw out the bad versions of this? I mean, one of the simplest versions would be you have an autorator look at the chain of thought and say, this looks sus, don't do it. E.g., this mentions eval awareness, kill it. And I haven't really seen people investigate this kind of thing. That wouldn't surprise me if I just have missed the relevant papers. I think that this might be less cursed than directly training against the bad thing, because the model has much weaker gradient signal. It's more like you're putting it in some like weird warped universe where it just could never do eval awareness. And this should probably give some gradient signal to, but like, it's pretty unclear to me what, if anything, this should do. But yeah, these are like my main takes for what Interpy people could do to help with alignment, and kind of what I meant by the category of steering fine tuning. I do feel like, can you steer RL by throwing away transcripts in intelligent ways? Does feel like it has the potential to be a good sprint project, or just like a high variance cursed sprint project. I'm not entirely sure. But yeah. And let's.
The problem there would be like setting up the RL environment.
Yeah, I think, can you find a decent open source language model RL environment that you can copy and replicate would be an important question. I'm sure those exist. Whether there exists any, if anything interesting, is like less clear. Hell?
Yeah, on the using a probe to like filter data, I am trying to understand like why maybe it wouldn't just be better to have an LLM do that. Like where would be the advantage of using a probe?
Probe's cheap.
Yeah. But like, I don't know, like, are they that much? I guess they are much. There's only
Yes.
one token you have to generate as opposed to like a lot.
Mhm.
That is true.
Well, as in, so at least, so probes are cheap if you are already running the model over the data, which in the case of RL, you are. So if you can have a probe on the model during this, then it's like essentially free, while running another model on it could be expensive. I think that like for RL, it's not that big a deal, because typically the amount of effort required to do the RL thing is just not that high. And so, well, like, sorry, the amount of compute required is like not that high. So if you were to double it in exchange for being much easier to align, that would be acceptable,
Mm.
in my opinion, maybe.
I mean, I guess like, but you could also just have the episode and have a prompt that's like, is this good or bad? Answer yes, no. And then you get like one token from the model.
I trust that so much less. And I feel like, yeah, there's just like so much tied up in like what the model will say in response to that in a way that doesn't feel true of like probe.
I guess this makes you
Ooh,
wonder. Oh, go
It's
ahead.
a good baseline.
Yeah.
And like sometimes the baselines that I'm skeptical of on principle are like actually just good. But yeah, and I think that like have another LLM look at the transcript and assess it according to some criteria is like probably what I would recommend doing if you were trying to de-risk this approach. Just like show that it's possible at all, and then figure out if you can do it more cheaply. It's also like not obvious to me if this will make a massive difference compared to just like train against whatever filtering you have. But it might.
I guess like one advantage of probe too is that you can like get weights for training data out of a probe instead of just like a cutoff. But I'm not sure if that's useful.
Yeah. I mean, you could also ask the model to output a score out of 10
Sure.
or something.
Yeah.
But yeah. Yep. I don't know. All right. So reasoning model interpret.
Like, I just do you tend to think of like probes as being like more precise in that like the probe has been generated by having some contrastive data that you've like handpicked maybe, whereas like I don't know, I guess you could show that like a model forms on some set of contrastive data that you've also handpicked. So maybe not.
Yeah. I mean, like, ultimately they're both classifiers. It's not very hard to evaluate how good a classifier is. So you should just do it and see what happens.
Thanks.
I think that, yeah. I think that probes are like really cheap and not the same as just asking the model, which I think in some situations is pretty good. Like, are you currently lying to me? Well, honestly, that probably would work on a lot of current models because current models are dumb. But I don't think this is a good solution.